Guys, are we live? I better. So, hi everyone. We have Conor with us today from Code Report, and he has a comparative programming channel which you should definitely check out. It's a very regular and consistent and well, maintained channel that he has. So Conor, can you give us an introduction to your comparative programming channel?
Yeah, sure. So I started this channel, I guess, just over 6 months ago. And the main reason I started it was because I, with myself, actively compete in competitive programming. And I was looking for a resource that would show video tutorials. So sort of walk through the problem and then walk through like a visual explanation of how you would approach solving that problem and then go through the code. Because a lot of the times you get, recommended to read other people's solutions to figure out how to solve a problem. But a lot of times that can be extremely difficult because, as we were talking before we started this stream, competitive programming, the code that you write to solve a problem, a lot of the times is what they call write once, read never code. So it's not designed for people to understand the algorithm that you're applying. So the goal of my channel is to sort of provide solutions that are easier to read and also to walk people through those solutions to help them figure out how to solve the problems that they were just on the edge of solving. And hopefully, I can improve through doing this. And then also the subscribers and the people watching the videos are able to improve as well.
Wow. All right. So you started this channel about a year ago or 6 months, I think.
My first video that I posted was on January 14th at the beginning of this year. So just over 6 months ago. Yeah.
Yeah, everyone remembers when they sent their first video. I still remember the 16th September 2016. I sometimes forget important people's birthdays, but
yeah, it's the first upload's a pretty big day.
Yeah. So it's been there's a few questions that people usually have when they're starting off with comparative programming as to whether they should join Code Forces or Code Chef or Top Coder, and there's tons of sites out there. So what do you think we should join? I mean, I think we both have our opinions. I usually ask for Code Chef because it's the site I started with. But I think in general, when it comes to a diversity of questions, maybe Code Forces is the one. But what do you think about this?
So yeah, we can definitely discuss this. I would say the question that you should answer first is, what is your goal from doing competitive programming? So if your goal is to practice for interviews, I would say, any site works, but the best site for that is LeetCode, because their site is specifically geared towards helping you prepare for those technical interviews, such as at companies such as Google, Amazon, Facebook, companies like that. If you're trying to practice for actual competitive programming contests, such as, ICPC or, the high school IOI. I'd say Top Coder and Code Forces are the best ones. And then HackerRank, I'd say, is my favorite just because it's the easiest to use. They offer editorials. I really like Code Chef as well. I wish Code Chef would post the data. So a lot of the times you'll finish a Code Chef contest and you'll be failing one of the problems, but you feel like you have a correct solution. But something that really, really helps is being able to go and look at what was the test case that you failed. So each site has their pros and cons, but it's more sort of, what's your goal? If you're just doing it for fun, I think sign up for, all 6 competitive code contests, or those are the ones that I cover. But there's also @Coder, and there's a couple smaller ones. Like, I just say sign up for them all and do the contest whenever, you don't have class. If you're a student or you're outside of work, that's a big thing. Like, if you work 9 to 5, a lot of the contests you can't do Code Forces because they're during the workday, at least for me. So what do you think, though? What do you think is the best site for, I guess, beginners?
Well, I started with Code Chef, and now that I've evaluated all the sites, it seems like, Code Forces does have a really clear comparative programming aspect to it. While Code Chef is, Code Chef is a company which is trying to improve education in general. So yes, they have a different kind of mindset when it comes to putting problems out there. There's also a little bit of, should I say, reliability issues sometimes. especially in the short contest. I don't know. This is really old experience. This is 4 years ago or 3 years ago
Mhm.
when I used to have some issues with the platform. But in general, I like it because I started over there. But if a person says that where should I start right now, I would probably say go for Code Forces. It's got this really nice and reliable side thing. And like you said, the test cases. Although there's pros and cons on that, because if a person is really getting the debugging skills sharpened, then like in the real world, sometimes you don't really know um, where the code will fail. So figuring
Right.
that out is one thing. Although Java does throw an exception, so that brings me to my next question. Which language do you think is the best?
Yeah, so we were chatting briefly about this before. So I would say, although we might slightly disagree on this, that C++ uh, is the best if you're going to do, pure competitive programming across all the different sites. At one point, I was looking into the statistics of, what different languages are used, and definitely the three top languages are C++, Java, and Python. But at least on Topcoder and Codeforces, it's about 85 to 90% C++. And that's purely because on different sites, some of the sites, they actually give different time allowances. So on HackerRank, if you code in C++, you get the regular time limit. If you code in Java, they'll give you 2 times the time limit because Java is roughly twice as slow. And if you code in Python, you'll get 10 times the time limit compared to C++, because Python is way, way slower than C++. But on a website like Topcoder or Codeforces, there's no ambiguity. They don't give different time allowances for different languages. So for certain problems, if you're doing like string parsing, Python might be amazing because it's way, way easier to do that than compared to C++ or Java. So I'd say HackerRank, leak code, choose whatever you are most comfortable with, / if you're going for an interview and you need to code in Java or Python, choose that language, right? There's no sense in practicing C++ if, 2 weeks later, you're just going to be coding in something else. But if you're competing across every site, I would say C++, then probably Java, and then probably Python, just because of the speed. But if you're not concerned about speed, then it's really just sort of what are you trying to learn? What are you trying to improve on? What do you think?
Well, from my side, I think you're right. I mean, I know you're right. C++ is fast. Also, many Spodge problems actually cannot be solved using slow languages because it gives you that much processor, that much of a memory, and source code limits, and everything is limited. And there's, like you said, there's no extra privileges you get for using one of the high-level languages.
Right.
So, but CodeChef and the others try to take that into consideration. So, in general, if you're looking to improve your coding skills for placements or an interview, then yes, I would suggest sites like HackerRank and CodeChef also in some ways, because these sites are regularly monitored by large software organizations. And if you're looking for the sport or the competitive bit of it, then yes, sites like Spodge. Spodge is mainly a practice site, but yeah, places which don't have any preference for a particular language, that's the place maybe where there's a lot of algorithms being put up. There's also another misconception that people have for languages being slow. In the comparative programming environment, they are slow, but when it comes to the real world, there's people who have this thing that C is the fastest and ASM will be faster. There's also in the job environment, what matters more is getting the code out quickly. So maybe Python is going to win every day soon enough. But there's also multiple threads that we can use, multiple processors. In that sense, when we are writing a very large application, usually Java is used because it's got good things overall. But I think Python is coming up as a big language now.
I think that's one of the main reasons why Java is a lot more widely used in the industry. It's like, I think it's considered the #1 most popular language at the moment, although Python might overtake it. And that's because the library support for Java is way, way, way better than it is for C++. Like, trying to set up a little GUI or a graphics thing in C++ is rather difficult because we don't have built-in support. So you're going to have to go and set up some sort of third-party library, and also package management for C++ isn't great. But for Java, like Java wins hands down when it comes to that stuff. And Python, I would say, even wins even more. But it's a much newer language, and it is 5 times slower than Java. So still, Java a lot of the times is what people end up going with when it comes to industry work. So you mentioned something about large companies monitoring these sites. So have you personally heard of people, had people or companies reach out to them because they were actively competing on these sites? Like, how often does that occur, if it occurs? And is it a good way to sort of get an interview at a top company if that's what you're looking for?
My personal experience is yes. I mean, I was one of the people who was contacted because of CodeChef. There are companies which monitor code forces, and if not, even if they don't actively monitor it, the thing is passively they understand what this means, getting a good rank on one of these sites. So if a person submits their resume, it's taken into consideration. It's one of the things which is considered a really good thing, because you're on a coding contest platform. And if you're performing well, you're showing that you're competitive, and you're showing that you're good at algorithms and coding. So a few of those things are taken into consideration. I think a lot of the larger organizations, when we are thinking about Apple, Google, Facebook, Amazon, they do ask questions which are centered around algorithms. And if a person is good at these sites, even if it is not taken into consideration, I'm sure the back of their head, maybe the interviewer might think about it for a minute, and maybe they'll ask a tougher question than normal. So
Yeah. I can personally attest. I've interviewed at a lot of these top tech companies, and they ask questions that are not identical, but a lot of the times, if you do these contests actively, you'll get a question, you're like, oh, that's very similar to a question I had before with a slight twist. So if you practice this stuff and do this stuff all the time, it definitely helps in interviews. Yeah.
Which brings us to the point of, what do you think is similar between interviews and coding contests? Is there any similarity, or do I have everything wrong here?
No, you're definitely correct. There's a huge similarity. So I guess it's easier to start with what's the biggest difference between a tech interview and a code contest or coding contest, and that's the purpose. You want the interviewer to be able to understand your code. You want it to be readable. You want to write, a beautiful solution that's elegant, and that's not necessarily always the case when you're doing a coding interview, or a coding contest. The goal there is just to finish the problem as fast as possible, and you could care less about the syntax that you use. If you want to use macros in C++ or some shortcuts that make things faster, that's definitely recommended, and what all the top competitive programmers do on these sites. But in an interview, you definitely don't want to do something that's completely obscure, and it's going to make the interviewer ask, oh, what are you doing there? What does that mean? I've never seen that before. So typically, what you're taking from the coding contests is the algorithm knowledge and the data structure knowledge and the time complexity of, what's the difference between, using an array versus a tree map versus a hash map, and sort of the time complexity of those data structures and how you combine those with algorithms to solve problems. And then in an interview, you're going to try and use that knowledge to write some beautiful code that solves their problem in as readable fashion as possible. So I would say that's the biggest difference. And then everything outside of that is very, very similar. Like, obviously, you're not going to get asked behavioral questions in a coding contest. You're not going to solve a problem and then they're going to say team environment, how would you do X, Y, or Z? That's not the purpose of a coding contest. And you're definitely going to get that kind of stuff. Not for all companies. I've heard Google is less interested in sort of those behavioral questions, but Amazon and other firms, they definitely do have a mix of it. But when it comes to sort of the problems, it's all the same, really. You can use whatever language you want. You can solve the problem and approach it however you want. I would just say it's the quality of the code that you're writing is the big difference. Would you say is sort of the same, or what are your thoughts?
Well, I think, yeah, it's a split personality thing we have. During a contest, we have, get this thing working quickly. You need the time complexity to be really nice. If you know that the time complexity should have passed this, then we try to optimize the code. And in an interview, you go into the other personality where, oh, I need to write really nice code now, and the variables must be nicely named. What happened to me when I joined an organization, the first time I wrote code over there was just the way that I wrote comparative programming code. And yeah, the validator actually told me that, okay, just delete this file entirely and start over. So it doesn't make sense to name the variables AA or stuff.
A, B, C, D.
ABCD, yeah. ABCD would have been the case had I run out of variables completely, but it was more like A, B, and then let's go for AA.
Yeah.
And yeah, so like you said, one of the important things about coding contests is that they make the complexity of algorithms something that we can evaluate very quickly. So it's on the tip of our fingers. But the coding practices that we need to follow are something that we either learn in our organization or through internships or through actively reading code, either through open source, or maybe if you go to your teacher who's managing your project and tell them that, hey, is there something that I can improve on? Most likely they'll say that, yeah, how about understanding this code?
Yeah. So you mentioned time complexity and trying to go for the most efficient solution. So I've heard differing opinions on when you're in an interview. Say you've got a question where you know that there's a quadratic solution, an n log n solution, and a linear solution. The question is, should you just go straight for the linear solution, or should you mention that, oh, there's a quadratic and a linear rhythmic solution, but I'm just going to focus? Or should you one by one, like I've heard some people say you should start with the worst case, explain that, and then improve from there. And I've heard other people say that's a waste of time and it makes it look like you don't know the optimal algorithm. You should go straight for the linear and just disregard. What are your thoughts on that?
Well, I've seen this happen in front of me. I mean, when I've taken interviews. So if a person goes from quadratic to log n log n, and then goes to a linear solution, most of the times those solutions don't have any connecting point. So what I'm seeing is a lot of ad hoc jumping sometimes. And if a person does tell me a brute force solution which has n square, then it's not really saving his or her time, because I'm still waiting for a good solution. It may, if not the best.
Mm-hmm.
The second point is that, yes, order n is something that is the best, but it's best to talk about the best thing, because it saves time, and it also shows me that, yes, this person is prepared. In the worst case, I don't know about how much they can break a problem down to simpler parts and then solve them individually, but that's okay. I mean, as long as you get the solution, I have to pass you. There's no real, yeah, there's no real advantage I see of beating around the bush.
Right. So if you know the best solution, you should just go for that one, because you're just wasting time that could be asked on other questions, basically.
Right. And if you know so many solutions about a particular question, it also should ring your alarm bells, that maybe the interviewer is thinking about a second question, a follow-up question. So best to get this out of the way quickly.
Mm-hmm, mm-hmm.
So you're currently working in, I think you've switched companies now, or is that the case?
Yeah, so actually yesterday was my last day at a firm that I've been working at for 5 years. There I was coding in C++, and it was sort of a insurance software program. But so I've got a week off now, and then I'll be flying down or moving down to the States, where I'm going to be working at Amazon.
Oh, wow.
So
Amazon,
that should be, I think, 50 or half and half Java and C++. So I'm going to be learning your expertise in your language. So I guess we're going to be closer friends after that.
Java. What's Java again? C++? Well, I should learn a little bit of C++ too. There's a lot of people who ask me that, could you post a solution on C++? And I just can't make myself go through learning a new language again, unless someone's got this big stick threatening me with, you're going to get fired. You better learn that Python thing that we were talking about. It's really difficult to learn a new language, and I don't really see how that is going to benefit me, personally. Professionally, it might. I should probably learn a few languages like functional programming, Scala. I should probably understand C++, because that will probably give me a deeper understanding of garbage collection. But it's one of the things, as a programmer, I can confess that it takes time and it takes a lot of effort to actually learn a new language. It's just like learning French when you already know English, and you have this thing at the back of your head that, oh, well, everyone speaks English, and that's not true, but It's a way to get over it.
Yeah, no, it's actually interesting that you say that it's, I do think there's value in learning other language, but as you just mentioned, there's something in, computer science or software engineering called programming paradigms, and sort of different languages fit into different programming paradigms. So one of the paradigms is functional programming. And then there's sort of object-oriented or procedural. And so Java and C++ are very, very similar to each other. The big difference being that Java has GC, garbage collection, and C++ doesn't. But going from Java to C++ or C++ to Java, there's not going to be a ton. You're not going to be learning a whole new programming paradigm. So there's a lot more value to learning like a functional, like if you already know Java or C++, learning something like Scala or Haskell or some functional programming language, there's a lot more value to that. So, and that's, I try and cover in some of my videos, both, the C++, the Java, and the Python solutions. And the Python might look drastically different, but a lot of the times the C++ and the Java, because in competitive coding, you're writing just a small piece of code. Garbage collection usually isn't a big deal. You're not usually deleting, your memory that you've allocated in your C++ code that's, only 20 lines long. So a lot of the times, like the biggest difference is like the data structures that you use. In C++, you'll use a map, whereas in Java, you'll use a tree map, something like that. And each of them has a different API and different methods. But yeah, if I were recommending people to learn like a new language and they already knew Java or C++, I would recommend something from a different programming paradigm, not something that's in the same. It's always good to know more languages. But like you said, like there's not a ton of personal value that you gain just from learning another language that's very similar.
Absolutely. And it's interesting that you mentioned that 20 lines of C++ code, which probably means about 100 in Java and 5 in Python.
Yeah.
Yeah, it's one of those things. And also programming paradigms, like you mentioned, and that's absolutely the point I was getting to. It's you learn new things only when you approach a problem from different ways. And some problems are better approached from one language, let's say a functional programming language, versus some problems are better approached on when we go for a procedural programming language. Maybe procedural is something that the industry doesn't do too much. I don't know if it'll have a comeback or something, but functional and object oriented is something that they have a lot of focus on. Object oriented has been there for a really long time. We think of everything as objects and we objectify everything, but yeah, there's a lot of design patterns around that too. And it's one of the things which makes me think that if you get too constrained with one programming paradigm, maybe you start thinking about things also, algorithms and in general stuff in that paradigm. So yeah, I would like to expand myself using different languages.
I've definitely heard from more senior developers that when you learn a new paradigm, it starts to influence how you write code in the one that you use in your day job. So like, for instance, in C++, they're coming out with new versions similar to Java. Java, they have Java 7, 8, 9, 10. C++, they have C++ 11, 14, 17, and 20 will be coming out in a couple years. And in C++ 11, they added something called lambdas, which exist in Java and Python as well. Although Python, they're very difficult to use due to the white spacing requirements. But when you use lambdas with the STL algorithms, and it really opens up a new world of coding. Like previously using algorithms, without lambdas, you have to create function objects, and it's very difficult. But now with lambdas, it's really easy, and you can use something called an immediately invoked lambda that's very functional. It's a lot more declarative than it is imperative. And there are a lot of people that feel that this is a much better way to code. So if it's it does really add a lot of value. And like you said, it starts to you'll take something from that other paradigm and sort of apply it to the current language that you're using, and it's a great way to learn. Yeah, but like you said, it is a lot of work. It's not something that you're just going to take a weekend and like, oh, okay, now I'm a Python expert, or now I'm a Haskell expert. It takes months and months and years to really get good at different languages.
I get this a lot, and that's the reason why we are talking about this for in such detail. There's people who say, should I learn all the languages that there are? Maybe 30 languages. And then there's also people like, should I learn all the data structures and algorithms out there and then start comparative programming? I understand where they're coming from. They want their prerequisites out of the way so that they just get a straight shot at learning things, but that's not how things work. There's the beginner, intermediate, and then really advanced somewhere out there. And you have to start at some point, because Otherwise, like personally, I feel like I get scared if I don't start something, and there's that fear keeps building up as I get more and more prerequisites out of the way. If a person tells me that you need to be an expert programmer before you start comparative programming, I know that that person hasn't done comparative programming then.
Yeah, I completely agree. If someone's thinking about getting into competitive programming, but they don't think they have enough knowledge, just start. Like there's no better way to learn than to start competing in it. And there's different levels of problems, like you said, beginner, intermediate, expert. Even if you can't solve the beginning problems, read the solutions, and I'm sure after a couple contests, you're going to be able to start solving the first couple of problems. And also too, your rating will start really low, but it's really, really, at least for me, validating when you start to see your rating go up on these contests. So if you wait until you're an expert, then you're never going to be able to see your rating go up. It's just always going to be high. But if you start when you know nothing, then very quickly you're going to start seeing your rating improve as you start to solve more and more problems. So yeah, there's no reason not to start if you're interested in it. There's problems for every single level.
Okay, there's one question I want to ask, which is going to be pretty controversial, and maybe I'll have to take down this video later on out of fear. And that question is, where do you see most of your subscriber base or your viewer base? Is it India or is it other countries?
So yeah, so originally, because I'm currently living in Canada, it was overwhelmingly Canadian because most of the people watching were my friends. But then after about a month or two, I think the number one country was definitely the United States. But I think since if you look at the last 30 days, it's about 50% from India, about 20% from the United States, and I think Canada is down to like 2% or something like that.
Right.
So yeah.
Friends, there's only so many friends you can have.
Yeah. Well, I am a software programmer, so there are a very small number of them to begin with.
I get it, because I remember there was one viewer and that was my friend, and then I ran out. But yeah, well, that's one of the things. So in India, there's a lot of focus coming towards comparative programming or algorithms in general, because there's a lot of engineers we have, and there's a lot of them who are joining computer science, seeing that there's a good opportunity when it comes to jobs. So most of my time is spent answering questions. When I'm answering questions, that time most of my time is spent answering questions on job prospects and on how they can train themselves to be good at this so that they can clear their interviews. Do you think that's, I mean, this is a controversial question. Do you think that's all right?
So you mean training for interviews with these contests, or?
Yes, that's what I meant. Yeah.
So yeah, there's some disagreement on what's the best way to interview for these tech companies. 10 years ago, it used to be these like riddles that, a rooster lays an egg on top of a house and, the wind is blowing 5 miles per hour or something, which way is the egg gonna roll? Like, I don't really know any of these. Or like one of them is, there's 3 light switches and 3 light bulbs upstairs and you can only make 2 trips or something. How do you tell? I never had an interview with these types of questions, but I think mostly thanks to Google started doing basically like data tracking of like who performed really, really well in these interviews and then how did they perform on the job. And they basically found that there was like 0 correlation between performance on the job and performance in these types of interviews. They thought they were finding the smartest people out there, but really it was just people that had gone on the internet and memorized all the answers to these problems, or they just happen to be really good at these riddles. But it doesn't necessarily translate into being a good developer. And so the same thing is being said right now about competitive programming, that just because you're good at competitive programming doesn't necessarily lead to you being a good developer. Like you said, the first day you showed up for work, you started coding and then your manager said, okay, go delete that file and maybe try again. You don't want to write the kind of style of code that you're writing when you're competitive programming. But from what I've heard from the discussion is that even though it may not be the best way to interview, it's the best way that currently we know how to interview. And so there are different techniques. Some of them are just saying, just have a conversation about some personal project that the individual is working on, and you'll be able to tell if they're passionate about developing and writing maintainable, scalable, readable code. But at the moment, it seems like all the major tech companies are using this technique, and they seem to be doing pretty well. So obviously, it's not, it's not an awful mechanism for interviewing. But I would guess that in maybe 10 to 20 years, using these competitive coding sort of algorithm and data structures questions, the same way that we moved on from riddles, we're going to move on from these competitive coding problems. I don't know what the next style of interviewing is going to be, but my guess is at some point something better will come along. It's just a matter of when and just a matter of what. I'm not sure. What are your thoughts?
I agree. I think that those kind of questions, which were the 3 light bulbs thing, and you have to go there, that used to be dependent a little bit on luck also. There used to be the thing that if the person gets the insight during the interview, then they can solve the problem, unless they have already prepared it beforehand. In these things, these are syllabus based, or at least they are relevant to computer science. So the puzzles being asked are something that we can find a solution to using our relevant knowledge. So that makes a lot of sense. But there are people like, I think, I'm not sure, I'll verify this, but I think Peter Norvig, the guy who's an expert at artificial intelligence, mentioned that compared programming has a negative correlation to work performance in certain cases. When there's an extremely good compared programmer who joins a company, maybe you shouldn't hire the person. But that's strange. And if I think about all the things about correlating good programmers, and I see compared programming, I would say that yes, algorithms are taken care of to some extent, speed coding. So these are positive qualities, and yet we are seeing some odd things occurring when it comes to great compared programmers in software engineering positions. So I'll just mention something that's been in my mind for a long time. I think it's because we take this solving algorithms too frantically. Like we study a lot of algorithms and a lot of data structures which may never be used in the real world.
It's a good point. And I have heard that before about the negative correlation, but I'm not entirely sure what it's due to. I think part of it probably is, like you mentioned, it's people that are used to just coding in that one style. And if they've done that their entire university and they've never worked at a software company where they have to write readable code that other people can read, and they have to think about when should things be put into a function, and how should I design a class. These are things that typically you don't think about at all when you're doing competitive coding. So my advice would be, choose the language that is your favorite, and, go and find online lectures. Like right now, there's a ton of resources online for free. A lot of conferences, like mainly the conferences that I watch are the C++ conferences, but, they have C++ Now and CPPCon that release all of their lectures and talks that are given online for free. And in these, they're talking about, best coding practices and the way you should approach, designing X and Y. And those can really supplement, all the algorithms and data structure stuff that you're learning from the coding contests. That stuff you can take in the interview, and they might ask you, how are you going to design, something like the Java's big integer? Like that's a classic, interview question that you'll get where they say, how would you design that? And if you're just doing coding contests and problems, you're never going to write a class and think about, what's the best way to design this API. And so we might start seeing, websites pop up like that are, design a custom linked list or design, this type of class. And then somehow you'll get graded on, how well you design that class, because that is something that does come up in interviews as well that doesn't get covered by these sites. But yeah, I'd love to see, like, if they have statistics or data, like what causes, like, are they able to tell what is the relation between, the peak competitive programmers and poor performance? What is that?
That's true. I think some of the theories that people have is that it's like taking an Olympic level swimmer and asking them to be a lifeguard. So they may not be the best at that job because it requires a different kind of skill set. Although swimming is an important bit, but it's like a person with really large muscles. Maybe Mr. Olympia may not be the person who's lifting the heaviest in the world when it comes to Olympic weightlifting. And yes, there is correlation, but it may not result in the best player out there. So yeah, that's an interesting thing to think about in a way. like you said, to avoid that, what we can do is we can keep things relevant. We can look at what software engineering really is, which is basically solving problems. And solving problems is not necessarily solving algorithms. I mean, getting algorithms. It's also about uh, not just writing good code. Also, it's also about designing systems and also about uh, working in a team and stuff like that. Which, of course, will be very difficult to teach unless you have an internship or something like that.
Right. Correct.
So, Conor,
Right.
do you think we should take? Am I pronouncing this right? It's Conor, right?
Yeah. Connor, that's correct.
Conor. Okay, Conor. Okay. What was I talking about? Yeah. Should
We
we
should
take
take
questions
some
from the audience
questions.
now?
Yeah. Let's take a look at some questions.
Okay. There's a question from Jatin Goel, which is, what do you think of higher education from IITs and CSE? Do it. Yeah, that's one of the things. What is the advantage of coding in Java? I think we have talked about this a little bit. It's about a lot of libraries that Java provides. It's not the silver bullet to a programming contest at all. I mean, you need to know the algorithm, but it's useful because you don't need to remember a lot of the libraries, and it's one of the popular languages. So if you're thinking about a job after this, then yeah, that's one of the good things. Okay. Connor, would you like to take a question? Of course. Can you see the questions? Of course, I'm sure you can.
Yeah, I can see them. I would say the advantage of coding in Java is definitely it's the most widely used language at the moment, I think. So if your end goal is trying to get a job out in the industry, Java probably is casting the widest net. But yeah, it's not a very specific question because it's not saying, what's the advantage of coding in Java with respect to competitive programming or with respect to what. So, but just in general, I would say Java is the most widely used language, and learning that is a great tool or language to have in your tool belt.
Okay, that's interesting. How about Kartar Singh? He has a really good question, I think. And that's, how do you balance learning, revising, and retaining what you learned? So, Kartar Singh, that's a brilliant question. I think we should answer that.
Well, what do you think?
Well, learning, revising, and retaining what I've learned. Learning is, in a way, simple. It's not easy, but it's simple. All you need to do is try that problem, and when we fail, we read on that question. So that's learning. When it comes to revising, now, when do you know that you need to revise that problem? Because the problem with me is, in the back of my mind, I always imagine that, yeah, I just did this problem yesterday, so why do I need to revise it? So that's a tricky thing. You need to understand that practice is important when it comes to coding, not so much the algorithm. So if you're preparing for an interview, that's the time when you'll be revising. That's the only time I can think that you'll be revising. And the more you revise, the less likely you are to forget what you have. So you'll retain. It's a very generic question. I think it's a good question. And when it comes to algorithms, just keep practicing contests when you will be almost forced to solve all the problems. So you will be forced to revise concepts that you already learned. It's
Yeah.
one of the things I think, Kona, is that you have these problems, right? And once we start solving them, when we join the next contest, a lot of the problems are similar to what we have already solved. So does it get boring at any point?
No, so well, I'll answer that question and then I'll go back to the other question. But no, like for me, it's at this point I do it for fun. I mean, I always loved like logic puzzles and crosswords and things like that when I was a kid. And this is like the purest form, and like math contests as well when I was in high school. This is like the purest form of that. You're given, a tool set that you have to learn, and then you're given these different problems. And yes, there are problems that are very similar to each other. But I have yet to see a problem that was like identical to a previous problem that I saw. I'm sure it'll happen at some point, but it's usually like a different flavor. And that covers exactly, how do you balance learning, revising, and retaining? Retaining, a great way to retain is when you see a similar problem, but it's a slightly different flavor, and using the same algorithm, but what you code is not going to be identical to what you coded before because it's slightly different. But yeah, so I find it incredibly fun. If you're trying to get into a tech company and this is the way you're preparing, and like you're hating the hours that you're spending on these algorithms and data structures and stuff like that, I would seriously, try and you take a step back and, there's tons of different software development roles out in the industry. There's tons of different positions, and if you're not liking the data structures and algorithms one, I would consider maybe trying to take a different approach and see if there's a different kind of engineering position that you would be better suited for. Because when I'm practicing for this stuff, like, it's incredibly fun. Like, I feel lucky that I, in preparing for these interviews and for, learning how to code better, it's like a game, like some people play video games, and, I get to do competitive programming, which is a lot of fun.
I think you mentioned a very important point. There's a lot of people who consider programming to be the easiest way to get a job. I would say it's one of the most efficient ways, even now. But if you're not enjoying it, it would be better if you invest your time and effort on projects.
Mm-hmm.
And if you invest your time and effort on open source things, maybe on getting internships, maybe on really improving the system that you're built in college or something. Because comparative programming is not easy if you're not interested in it.
Yeah, it's really hard to learn anything that you're not having fun while you're learning it. And there's tons of other ways. Yeah, like starting your own project, contributing to some sort of open source thing, and that has an entirely different skill set. You can't be checking in competitive coding code to an open source project. It's gotta look good. Yeah, it is a great question.
There's going to be that pull request, and then there'll be delete that file.
Yeah, what you don't want to see.
I think Abhishek Verma, How to Improve and Compare Programming for Beginners, having very less knowledge about algos. One of the prerequisites is algorithms, but you can learn it during comparative programming. It's not something that people join knowing very well. So yeah, just start. Like we said, just start. And one other good question that I saw was, how do you balance between development and comparative programming?
How do you balance between? Sorry, what was the first one?
How do you balance between the software development we do in our jobs, so training for that, versus training for interviews and algorithms through comparative programming? So how do you keep both of them?
Yeah, that's a great question. And so what I've actually tried to do, especially with the YouTube channel that I started, is solve the problem and at the same time learn best practices and figure out ways to write good code that actually could be checked into a system, or a production code base. So, a lot of the times the code that I write and then the code that I show in a solution video is going to be drastically different. And it's a great way, if you know who Sean Parent is, he's a really, well-known C++ developer at Adobe. And he's given multiple talks online, and one of them is called C++ Seasoning. For anyone in any language, I would recommend going to watch it. But he's always talking about, know your algorithms. And with C++ comes a library called the algorithms library. And so a lot of the times, knowing these algorithms can drastically simplify the code that you're writing. So for instance, I actually saw a competitive programming question that was basically, given a sequence of characters, find the next sequence of characters that you'd find in a dictionary. So basically just rearrange those characters so that if you were to generate every single permutation of those characters, what's the one that would come right after it? And there is specifically a function in C++ called next permutation that does that for you. So literally you can type one line of code, next permutation, pass it the range of characters, and then you're good to go. Whereas if you have to code that from scratch, it's not going to be trivial. It's not the hardest problem in the world, but it's definitely not going to be as easy as just writing, one problem. And there's also in C++ 17, which currently only Codeforces supports, there's a new numeric algorithm called GCD. So yes, GCD is very easy, greatest common denominator or divisor for those that don't know it. It's a very simple function to write, but if it's built into your language, that simplifies things greatly. So whenever you see something GCD, you're like, oh, okay, well, I've already got that built into my language. So that's a way that you can, in your production code base, you're assumably going to be wanting to use the APIs that are provided with the language. If you're using Java, it comes with a ton of libraries. Don't rewrite things that already exist. And so, try and find a way to integrate that into the way that you write your competitive coding solutions. What do you think? Is there a better way to sort of balance development and competitive programming?
I think what you mentioned is absolutely correct. It's just staying aware of both the fields that we are trying to work on. And it reminds me of this time when, again, when I had started off my software engineering career, there was this manager of mine who said that I'm going to give you a file and I need you to remove all the duplicates from that. And I wrote this long Java code which had a hash map and stuff in that. And then he looked at that and then he wrote a single line of code in the bash script. And then just dot minus u. No. That's what happens sometimes when. So that's the reason why we need to be aware of different languages also. But yeah,
Yep.
That's what happens sometimes. I think you had a. I mean, there's lots of questions that people are asking which are interesting. Older
Is
version.
competitive.
Yeah, GCD.
Or sorry, I was gonna say, is competitive programming the fastest way to get a job in Google?
Yes, it is. Of course. Please subscribe to both channels right now.
Yeah, subscribe to both channels if you want to work at Google.
Yes. Not just work at Google. If you want to work at 3 companies at the same time, especially if you want to be the CTO immediately, this is the fastest way that you can. That wasn't. I mean, was that a joke? I don't really know. Isn't the CTO of Google doing compared programming every day? Well, I do get
I'm
this.
pretty sure that's.
I do get this question sometimes. That is, to be a great to be a great programmer, do you need to be a comparative programmer? And what are your thoughts on that? I'd like to get them first.
What do you need to be a great competitive programmer?
No, to be a great developer, software developer, do you need to be a comparative programmer?
Oh, if I was only interested in my sub count, I'd say yes. But the truthful answer is, most software developers, the best in the world, I'm sure some of them do competitive coding for fun on the side, but most of them don't, because they're, working for huge companies that are paying them, large sums of money, not to competitive program. It's to develop on their code base. And I'm sure there are some amazing developers that have never even touched competitive programming. So although competitive programming can be a way to, help you become a better software developer, you definitely don't need to do it in order to become one. I'd say it's a better tool for getting into the company than it is for developing, software development skills and such. What do you think?
I think that's an incorrect statement. Like I said, to be the CTO, you do need to have certain knowledge about algorithms and data structures, at least to heavy light decomposition. Otherwise, you're in trouble because you're going to face those situations every day.
Yeah. But so I guess I would say, yes, you definitely need to know algorithms and data structures, but you can learn them sort of outside of competitive coding.
By the way, I mean.
Oh.
I mean, of course not. Of course not. Okay, let's think about it this way. Do I really need to know about heavy light decomposition? Do I really need to know about really, really complicated algorithms? And the answer is no, because if I need that, then I can get to a researcher, pay them money, and get the job done. Now, why shouldn't I do it specifically? Because that's not my skill set. Simply put, a researcher can probably do that, come to me and can then write the code in an optimized way. This is my understanding of things. If it gets to a point where heavy light decomposition is something that software engineers do on a regular basis, then I need to know about it. That's how I think about it. It might be wrong. Maybe 5 years down the line, this view of things is going to be obsolete. But at least in the current things that I see right now in the software industry, I see a lot of focus being on user-centric things. And I think that's going to be there forever, because a business is for the users, not for solving difficult mathematical problems. So when people have priorities, I would say that, if you're good at compared programming, and by good, I know you hit a plateau. And that's when you know that it's okay. You might just switch your focus to different things. I think that's perfectly fine, instead of just going for rank 1 or something, because oh god, maybe I made too many controversial statements in one single talk. So.
No, I think it's a good point. Yeah, it's you'd be surprised though. Some of I believe his name is Sanjay Ghemawat. I believe he currently works at Google. Correct me if I'm wrong, but or maybe I think he's hopped around. So at one point he worked at Amazon, and at one point he's working at Google. But he's considered, one of the brightest algorithmic minds in the world, and he's super, super senior at Google. So there are people, or at whatever company he currently is at. I guess I should look up maybe on LinkedIn, although he's probably not on LinkedIn because he's so successful. But so I remember reading a couple Google books, and he was definitely mentioned in it. And you can become super senior even if you are this data structure algorithm expert. But the stuff that you're solving isn't going to be competitive coding problems. It's going to be creating the most efficient hash map that the world has ever seen, by looking at how the different bits, the ones and zeros, are stored on disk and stuff like that, and making optimal usage of stuff that I don't understand. But there are very senior roles for people that know that stuff. So if that's your passion, don't think that you're always going to be stuck at the most junior developer coding this and that. Like, definitely there are super senior people that this is their passion, it's what they're good at, and they can rise through the ranks. And I think that's one of the nice things about tech companies, is whereas if you work for sort of a financial company or some sort of corporation, they don't necessarily, they want people that are going to be great leaders and great managers, and those are the people that rise through the ranks. It's not always the people that are best at the day job, in sort of the nitty gritty work. Whereas at a company like Google or Amazon, if you're amazing at that stuff, like, they're going to promote you, and you will rise through the ranks still, which is a great part of working for a tech company, because they want super technical people.
That's completely true. I think the landscape is changing. I don't know how long it's going to be this way. I think it's going to be even more focused on specific skill sets, as we're getting more and more people specialize in really niche areas sometimes. And yeah, it's become a little bit on the whole soil of business in a way is getting tilled all the time. So the lowest level of soil is also coming up. So it's fun to see this, I think.
Yeah. Here's another question. It says, as you suggested, when you look at some solution from an expert on one of the sites, you can understand some of it, but not all of it, even after Googling it. Can you help me, or how do you deal with this? So I'm not sure. Do you have an answer for that?
It's a tough question. If Google is not answering our questions, and so after Googling and reading blogs and not figuring out how to solve that question, that's going to be very rare. It's going to be something that we are probably not able to understand, because we need some prerequisite for that. If others are able to solve this problem, and Google has some resources which we are not able to understand, we have to take into consideration what are the prerequisites. And maybe we can focus on that, getting that cleared. For example, there was segment trees, which I was trying to learn, and it was a complicated algorithm initially for me. And the thing I did was I sort of got my binary number knowledge clear first. And then I started understanding how trees work and why the complexity is going to be log n. So once I got these prerequisites out of the way, I could understand segment trees much better. So that's how I would take it, yeah.
That's a great point, yeah. So basically, if you're trying to read a solution that requires requisite knowledge that you don't have, it's going to be almost impossible to understand that solution. You might be able to read it line by line by line and understand each line, but you still don't understand overall what it's doing. So, my recommendation in general would just be try to, use solutions or solve problems that have editorials with them. So, I think Topcoder just started doing it. CodeChef has been doing it for forever. HackerRank is doing it. LeetCode is pretty good as well. And they even have other people posting their own different solutions with explanations. I'm pretty sure HackerEarth has it too. So that's almost, and Codeforces has an editorial depending on the writer of the questions, and usually they do. And so almost every single site has editorials for these questions. So try and find an editorial. Like, sometimes it's not always easiest just to read the code and understand it from just that solution. So I think at one point Topcoder didn't have editorials, and it was really difficult to look at a piece of code and reason what it was doing. But now I think almost all of the major sites have these editorials. So you should try and find them and read that first. And like on HackerRank And I think on CodeChef too, they'll even tell you like in a little box, what are the prerequisites, sort of like data structures, or, if it requires square root decomposition or segment trees, it'll say that up in a little bubble, right? Even before you read the editorial. So if it says that and you don't know those, maybe go try and read and learn about those first, then come back, and that's going to, assist you a lot more. And that's probably my best advice.
That's great advice, I think. And I forgot to mention this. In case you're not able to solve the problem, search for editorials. Editorials are posts written by either the author or the tester on this problem, and they explain how to solve the problem. Okay, so if you don't get a problem, that's fine. Search for editorials, and I'll just type that on the chat. It's something that a lot of people have doubts on, so I'll just get that out of the way. And they explain how to solve problems. If you're not able to solve the problem even after reading the editorial, you have probably read a Codeforces editorial, and you need to then do something about that. Well, Codeforces has a single line editorial sometimes. What?
Those, I think, are my best videos, are the ones that on HackerRank, there's an editorial, but it's just almost next to useless. And I'll say at the beginning of the video, there is a HackerRank tutorial or editorial, but it's a little bit hard to understand. And usually those are my best videos, because most people, if they can read the editorial and they understand it from there, they don't really need to go and watch a 5 or 10 minute video explaining it. But if there's a problem that has an awful editorial and there's no way to understand it, that's when videos like that are really helpful. Unfortunately, I don't make them for every single video. So there's still going to be problems that people are going to be asking, oh, I still don't understand this. But, hopefully as time goes on, I'll be able to pump out more and more and more videos as I get better and better and better.
I think, yeah, you're right. There's also the human limit that we have as people. We have our jobs, and then contributing is something that we find very, very fulfilling. But there's a point after which it becomes impossible to contribute. So 2 hours, 3 hours a day, beyond that, it's just not possible. There's someone asking, I think, about what about machine learning and AI, I think, in the software engineering field. Well, my personal thoughts on that are, it's nice and you should study it, but it's not going to be easy, because like with everything new, it is difficult. Did that even add any value to anybody in the world? Did that statement add any value? I think, Conor, you should take this one. Yeah.
Sorry, what was the question?
The question was, what are our thoughts on machine learning and artificial intelligence?
That is a very general question. In general, I think it's super interesting, and it's one of the hottest fields in software engineering right now. If you have a PhD in machine learning or neural networks, or I guess genetic algorithms aren't as big, but if you've got a master's or a PhD in one of those areas, like, you're gonna definitely be employed, and you're definitely gonna be getting paid well. And I think,
Sorry, go on.
I think like a decade or 2 decades from now, everything is going to be driven by, like, you can already see it happening, right? Computer vision with self-driving cars. You look at every industry, and there's some sort of impact that artificial intelligence is having. And there's, Facebook AI research, there's, Google's DeepMind, there's Elon Musk's OpenAI, there's, all the top tech companies. It's just a race to see who can get the best AI system. You even saw it in, I think, Google's I/O event this year, as they switched their mission from, mobile first to AI first. And we're just going to see more and more as the years go on that, artificial intelligence and machine learning is just going to be influencing every aspect of the industry, of every industry, more and more and more. And yeah, if you have expertise in that field, you're going to do very, very well. And I think every software engineer over the next 2 decades is going to be learning at least a little bit about, like, so right now, everyone is starting, even people that aren't software engineers are learning a bit about Python. And I think as everyone starts to learn about, engineering, more and more, everyone's going to start to learn about, how to make use of Python's, machine learning libraries and whatnot. And I can't, so what do I think? I think it's huge, and it's going to get bigger and bigger. How it's going to impact the world is going to impact it in every industry, but only time will tell, right? I'm not a fortune teller. When will the singularity happen? I have no idea. How about you?
I think that's a great point. And like you said, it's going to drive everything literally. It's actually going to drive cars too. If you are in competitive programming and you want to shift to this thing, the way I did this was to solve challenge problems, the NP hard problems that CodeChef offers as a partial scoring. So that's one of the good places where you can start. You can also start with, I think Codeforces just had a contest right now. It's still ongoing as a approximation algorithm thing. So that gives you a little bit of a taste of what AI is. It's making concessions, understanding the problem at a very deep level, not just the algorithm that is going to solve it, but how do you optimize a solution mathematically. And I think that's what really interested me about AI. I then moved to Hacker Earth, which has their bot contests, and that taught me a little bit about at least game playing artificial intelligence to a large extent, and it's really really interesting.
Yeah. There's another website as well. Like, so if, listening to this,
Code in game.
Pardon?
I think it's Code in game that you're talking about.
Oh yeah. So there's a couple, Coding Game, and then also Kaggle is a really big one. Kaggle, and that one actually, I think Hacker Earth is the same.
Right.
Here, I can type it into the chat. Not that we want people switching away from competitive programming.
Of course, no.
But if you're sitting there listening, thinking, I want to be a software engineer, but really I want to be a data scientist or a machine learning engineer, and is this really the best way to get into a company like Google or Facebook, and do that? I would say, yeah, sure, practice your data structures and algorithms. But Kaggle is a site that's very similar to HackerRank, but it's specifically geared towards machine learning and artificial intelligence. And they offer like huge monetary prizes, like upwards of like $1 million American dollars. I'm guessing if you're just starting out, you're not going to win that. It's going to be some corporation, but there's tons of resources online where, yeah, there's different types of contests. Some are purely for competitive programming. Some are for, how to compete against each other. And some are just how to identify what a house is worth by looking at an image or something like that. Yeah.
I think that's an interesting point. It's Kaggle, personally speaking, when I went there, I found that the competition was really, really tough.
Yeah.
Because there's PhD teachers actually from MIT who are also out there, and you feel like really insignificant when it comes to that. But there are easier challenges that a person can pick up first, and they can do well over there. I think there's a scope over here for machine learning, a competitive machine learning thing. Kaggle is out there, but it's really, really difficult. It needs to be done for maybe specific countries that could help. Who knows?
Yeah, that's probably, we're probably going to see it, right? Like, I mean, if artificial intelligence is going to continue to grow and Kaggle becomes bigger than every other, if it becomes bigger than HackerRank, we're going to see the same thing that's happening with HackerRank, where Hacker Earth and all these other websites are starting up. We're going to see the exact same thing with Kaggle-like and Coding Game-like websites. Which is great. The more competitive programming-esque, whether that's AI or just pure computer science sites, the better.
Absolutely, and we'll change our content. So don't worry. Don't worry. Yeah. Okay, Conor, I think, is there any question that you'd like to take? Or, yeah.
I'm not sure. Well, there's one right here at the bottom for both of us. How long does it take to become an expert level in algorithms when you are somewhat at the intermediate level? Any resources that you would suggest? So what's the amount of time it takes to go from intermediate to expert? And what's the best way to do it? That's a good question.
That's a tough question. I think at intermediate, we all hit a plateau where we are really not learning too much. And then you have to go through the theory of algorithms and then come back. You have to relearn what we have learned and then do well. It's going to take some time. I would say expert is a relative thing. Intermediate is a relative thing. But for normal people, an expert would be maybe read on Codeforces or something. I think it will take at least a year. Practically speaking.
Yeah, it does not take a short amount of time in terms of the best way to approach it. So like, I'd probably say that I'm in that position. Like I'm definitely not an expert yet. I'd say I'm intermediate, and going from beginner to intermediate, I'd say is actually not that bad. Like just from doing the contests and picking up small little tips and tricks, when the first time you learn hash map or hash table, and that's got constant time insertion and whatnot, like those are really big wins that are going to help you with a lot of different problems. But then once you hit the intermediate stage, getting to the expert is learning all the esoteric algorithms that like are not widely applicable to a bunch of different problems. It's going to be specifically for that one geometry problem, or, you know, like geometry problems are like, I'd say probably the worst in that, like, there's all these different algorithms specifically for this one type of, like, you've got two circles and a line that goes by, and you need to know this one esoteric algorithm in order to solve it. And that's what makes the best people the best, is that they know all of these algorithms at the top of their head, and they recognize, they see a problem, they know, oh, well, there's that one specific algorithm that will help me solve that. Yeah, it just takes time. And my recommendation is to, whenever you compete in these contests, take the problem that you weren't able to solve, or that, you know, if you solve 3 and then just sort of stop, like take that 4th one and focus on learning whatever the prerequisite you don't know, like go and learn that and just keep on doing that. And it's going to take, like you said, a lot of time. There's no sort of quick way to learn all those algorithms. And there's no one fast solution.
Oh, that's true. It also is one of the things that I have been thinking of sometimes, as to should I try to go on the expert level, but then the time investment, like you said, is not is non-trivial. So yeah. One final question, I think, is from Kunwar Pratap Singh. He says that I want to get into deep mathematics of RNN, which is, I think, recurrent neural networks, Markov chains, and reinforcement learning. From where should I start? I would say let's just go along that sentence and pick up the first thing, recurrent neural networks, because I'm an expert in this field. Yeah, you shouldn't have asked me that question, should you? All right, then. Thank you, everyone, for watching. Thanks, Conor. I think it was a very fruitful discussion that we just had. I think it's brilliant, and we should definitely talk a lot more about comparative programming and just contribute more to this community that we have. So, what are your thoughts?
Yeah, no, I completely agree. I thank you so much for having me in this discussion. I think, yeah, we should try and do this again sometime. And if, you know, people are always going to have questions about how to improve, and, you know, both of us are only going to continue to get better. And yeah, I think this is great for the community. And I encourage everyone that's watching, if you've got friends that don't, you know, do competitive programming, but they like these sort of things, you know, introduce them to it. And I think LeetCode, I released a tweet, you know, 6 months ago or a few months ago, and it said they had 40,000 users, and just in this few months, they've grown past 60,000. So we're just going to see competitive programming continue to become bigger and bigger, and yeah, continuing these types of conversations, I think, is great for the community.
Perfect. All right, then, guys, thank you, and we'll see you next time. Thanks for all your questions. Bye-bye, Conor. See ya.
All right. See ya.
Bye. Okay. I'll just